Hello, this is Ravi Ozarker, video number 13, AISC design and code check for the AISC 2021 Student Steel Bridge Competition. We're going to use GT-STRUDL to design our bridge in this video. Okay, so in the last module we looked at how the strudel input file can help us. Okay, I'm going to go in and save that file that we had generated, okay, in chapter number 14. I can just say Control C. I can close all my strudel sessions and reopen GT-STRUDL, okay. So far I'm actually on chapter number 15 in the PDF document and the Kindle book, page number 141 in the PDF document. Okay, so if you are in the command mode, I would just right click, copy and paste, and it runs the analysis and gives you the sum of forces along reactions about the x is equal to 0, y is equal to 0, and z is equal to 0. Okay. Okay, now how do we design this structure? If we go to steel design parameters, okay, I'm going to show you more options that are available in the GT-STRUDL user interface. Okay, if you go to steel design parameters, it allows you to assign ASD 9th edition or even go to AIC 15th edition code. Okay, I can say all members and just say OK, and what it does is it generates a command. Okay, so good, we know what those commands are. We can copy that into our text file, okay, and learn about those commands, so we don't have to memorize them, okay, or even run them again. Okay, okay, so once we've done that, then we go to steel design parameters again. Here there is a lot of design parameters, as you can see, right? The yield strength of steel and so on. Um, so um, if you want, you can basically play with some of these factors. Okay, so for example, yield strength of steel, steel grade is 836. I'm just going to use a different grade of steel, okay, and let's just make it a 992, okay, to all members, okay, and then click on OK. So that generates another set of parameters, okay. So we can say steel grade A992 all members. I'm going to copy and paste that here. This you don't have to do it. I'm just doing it just to keep a record, okay. Now we can put in commands, more comments here in that file. I can just say, Ravi inserted these commands on 4-9 2020. Okay, so April 9th we put in these commands. I'm going to file, save, so my checker knows when were these commands inserted. Okay, so you can put detailed commands also if you like. Okay, once that's done, now how do we execute the design checks? We go to first, this thing is not in the book, but you need to provide the load list. Okay, so if you go to results, active, inactive loads, here you can just say inactive all, and you can pick let's say just the load combinations, okay, to check the structure. Okay, load case 101 and 102, and click on OK. So load list 101, 102 basically defines the fact that, hey, when you do the AIC check, I want to use those load cases 101 and 102 only. Okay, now if I go to steel design, check members, okay, it'll actually pull up this dialog box here. You can define that I want to check all for axial and moments and so on, and shears. I want to do these checks for every single member at one at every sixth of the section. Okay, and then we can say that we want to do it for all members, click on OK, and boom, it actually does the design for you in text format. Okay, now the headings are right at the top. It's very fast, but you can see this is actually giving you the profile, the member number 1. This one actually has section number um, uh, you know 20 is the one that actually governs. Okay, so we can see what the actual and limiting ratios are, and if that member passed or failed. Okay, in this case it actually passed. So you can see there's a whole lot of members in this list, and some of these members have asterisks for them on the left hand side. Okay, that means that those members actually failed. Okay, and it's actually failing by a ratio of 1.027. Okay, in some cases. So 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 that might be just the L over R ratio and so on. So you have to basically check why these members are failing. Okay, and if the unbraced lengths are not correct, you might have to provide the correct unbraced lengths for those members. Okay, so now how do we see these results graphically? Now, we saw those results in text format, but you can actually go in and review these results in graphics also. Now that portion is not in the manual, but I'll just show it to you. If I go into results, STRUDL code checks, I can select members, and it actually shows you in red what members are passing, what are failing. Okay, so these members are failing most likely because of the unbraced lengths. Okay, so if I go actual to allowable and I color code those, you can see the ones this is like just the allowable stress ratios. You can see they're all passing, okay, because of these loads that we have applied. But if you go to KL over R ratios, you see those members that were failing have a ratio of more than 1. Okay, so maximum is 1.03. It might work, but you may want to go in and provide the correct unbraced lengths, or play with the section properties for those members. So that was the last video of this video series. I have provided you with some references and some more models that you can play with in the book. You can just copy and paste all that text into the command window and play with it. This demo version of GT_STRUDL is freely available to you, and you can download it from the Hexagon website. Just Google GT_STRUDL download, provide a few parameters and your email ID, and they will allow you to basically download the demo version. There is also a feature inside GT_STRUDL called CAD Modeler, which allows you to model structures using AutoCAD or BricsCAD. BricsCAD is a Hexagon product, and it's available also for free for a 30-day trial. So you can download that also, and you can read the user documentation of CAD Modeler if you go to help documentation of CAD Modeler getting started. This documentation or guide will get you through using a CAD environment to create analysis models and review results and so on. Okay, so I hope all this information has been helpful to you. If you find this information helpful, please comment and also provide us with your feedback. My email ID is in the PDF document. Okay, thank you and have a nice day. Bye bye.